Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we want to solve the system of linear equations by substitution and check our solution. So, if I look at this system of linear equations, I notice that I don't have x equals or y equals. So that's my first step. Let me label these equations. This will be equation number 1, and this will be equation number 2. And that'll help us keep track of what equation we're working with. So I notice that if I look at the first equation, this would be easy to solve for y. Y is already positive. It has a coefficient of 1. So if I take equation number 1, and so negative x plus y equals negative 4, and I add x to both sides, I will get y equals negative 4 plus x. Or we could also write this as positive x minus 4. That might be easier for some of you. Okay, awesome. Now that I have y equals x minus 4, y is equal to this. So I can take this and plug it in for y in our other equation, equation number 2. So we'll put equation number 2 over here. 4x minus y equals 10. And you'll see I left space because instead of writing y, we're going to write x minus 4. Now, it's very important that I put these parentheses here because I want to subtract y, right? Equation number 2 says 4x minus y. So I need to subtract all of this. If I didn't put parentheses, I would be saying 4x minus x minus 4. But what I really want to do is I want to subtract 4x minus x minus 4. So I need parentheses around those. Okay, and now I can distribute this negative. So we have 4x minus x, right? A negative times a positive is a negative. And a negative times negative 4, negative times a negative, is a positive, and I get x plus 4 equals 10. Let's combine our like terms. 4x minus x is 3x plus 4 equals 10. I can subtract 4 on both sides, which leaves me with 3x equals 6. And then to get the x by itself, I need to divide by 3 on both sides. And x equals 6 divided by 3 is 2. X equals 2. Okay, am I finished? Am I all done? No. Careful, remember I need to know what y is equal to also. So now I need to take this x equals 2 and I need to plug it in to one of our original equations. Which one do you think is going to be easiest to plug it into? I think number 1. I'm going to plug it into equation number 1. So let's take equation number 1. We have negative x plus y equals negative 4. It's getting a little cramped. Let me rewrite that. Negative x plus y equals negative 4. We're going to replace the x with a 2 because x is equal to 2. Plus y equals negative 4. Don't forget your negative here. I know that x is 2, but we want negative x, which would be negative 2. All right, so to solve for y, I need to add 2 on both sides, and y equals -4 plus 2 is -2. Ta-da! Now we're done, because I have x equals and y equals. So my final answer is x, comma, y, or 2, -2. Wonderful! Also, it says to check our solution. For the sake of space and time, I'm going to leave that up to you to check our answer and make sure that we are correct. Because we are going to move on to what we have for today, which is starting section 5.3. 5.3 is about solving systems of linear equations by elimination. Okay, so 5.1 was solving systems of linear equations by graphing. 5.2 was solving systems of linear equations by substitution. And now 5.3 is solving systems of linear equations by elimination. So after this lesson and next lesson, because this is part 1 of 5.3, we'll finish 5.3 in the next video. After the next video, we're going to have 3 methods, 3 tools that we can use to solve systems of linear equations. So we can solve them any way we want. We could graph them, we could substitute, we could eliminate. It all depends on what's the easiest for you and what's the easiest given the system of equations that you have. If you got a ton of fractions, graphing might be the easiest. Well, we'll see. So, our learning target for today is that you know what elimination is. What does it even mean? What does elimination mean in math, in a math context? Our success criteria is that you can solve systems of linear equations by elimination. So you want to know, what is elimination and can I use it? Those are the 2 things that we are focused on today. Let's remind ourselves what a system of linear equations is. It is a set of 2 or more, but in this class just 2, linear equations in the same variables. So we have y and x, not y and x and, z and q or something like that. Just x and y. All right. Now, elimination. We've saw steps on solving by graphing, steps on solving by substitution. Here are the steps of solving by elimination. So, step 1, which you might have guessed, we're not going to deal with step 1 in this video. The next video will deal with step 1, kind of just like we did with substitution. Step 1, and let me give you an example system of equations here so that we can have something we're referencing. Sure, there we go. We have a system of equations, looks something like this. So step 1 is to multiply if necessary, because it's not always necessary. Today it's not going to be necessary. Next video it will be necessary. So multiply, if necessary, one or both equations by a constant. This is just a number, by a number. So at least one pair of like terms, and when they say like terms, they're talking about x or y, has the same or opposite coefficients. So what they mean by that is the same number in front of x or y. So when they say like terms, they're talking about the x's or the y's. Oh, whoops. And I didn't put a y there, my bad. So we're talking about the x's or the y's when they talk about like terms. And then we want them to have the same or opposite coefficients. So notice if I multiplied this equation by 2, this whole thing by 2, I multiply this side by 2, and I multiply this side by 2, then it changes to negative 2x plus y equals 8. The whole equation changes if I multiply it by 2. And it's okay, remember that if I multiply an equation by a number, as long as I do it to both sides, we're fine. We haven't changed the equation. It looks a little bit different, but it is the same equation as long as I multiply on both sides. Okay, so why? Why would we want to have the same or opposite coefficients? Because that's the most important part of step 1. That's what we want to get out of step 1, is we want either our y's or our x's to have the same, like y has the same coefficient, and x has opposite coefficients, positive 2, negative 2. So why would we want that? Well, let's look at step 2. Step 2 says to add or subtract the equations to eliminate one of the variables. What does it mean to eliminate something? If we're on a singing competition and one of us gets eliminated, they get sent home. They're out of the competition. They are no longer here. So to eliminate something means to get rid of it. To not have it anymore. So if we add these equations together, what's 2x minus 2x? 0. They cancel out. They are eliminated. And y plus y is 2y, and negative 3 plus 8 is 5. So, that's why we would want to have opposite coefficients. What happens if we subtract these equations? Well, 2 minus negative 2, these come together and become positive, and I have 4x. Y minus y is 0. They cancel because I'm subtracting. And negative 3 minus 8 is negative 11. So now I have an equation with just x in it. That's why having opposite or the same coefficients could help us. Because in the end, I get an equation with just y or an equation with just x, depending upon if I add or subtract. And whether you add or subtract depends on whether they have the same or opposite coefficients. And let me highlight that actually. If we have the same coefficients, we will want to subtract. If we have opposite coefficients, then you'll want to add. And we'll talk more about that as we see some examples. So, step 3 is to solve the resulting equation. So solve whatever equation you get from multiplying by the number in step 1. And adding in step 2, adding or subtracting. Solve that to get y by itself. Then, step 4 says to substitute the value from step 3. So we get y equals 2.5. And you want to substitute that value into one of the original equations. So that part is kind of like substitution a little bit. And then that's it. I already have y. I'll find x. Once I plug this in, I will find x. Wonderful. So, maybe you understood what we were talking about here. Maybe you are horribly, horribly confused. Either way, I think it's time to jump into an example. So we're going to solve a system of linear equations by elimination. So, notice that in this system of linear equations, my x's, my x terms, have the exact same coefficient. They are both positive 3. And if I look at the coefficients of my y terms, They are the opposites. I have positive 2y and negative 2y. So we have a choice to make. If we add the equations, we're going to get rid of the y's. If I choose to subtract the equations, I will get rid of the x's. Personally, I think it is easiest to add, because when I subtract, I have to remember to make everything negative, like that I'm minusing everything instead of adding it. So for me, it's going to be easiest to add. So remember, we're skipping step 1 because we don't have to multiply by anything. I don't need to multiply, right? This is only if necessary, and it's not necessary. I already have the same and opposite coefficients, so I can jump right into step 2. So let's add these equations together. 3x plus 3x is 6x. 2y minus 2y is 0. The y's are gone. So I can just write equals 4 plus negative 4. Oh, 4 minus 4, that's 0. Okay. Now we're on to step number 3, which is to solve this. Solve for x. So I'm going to divide by 6 on both sides, and I get x equals 0, because 0 divided by anything is 0. Okay, and now we're already on to step number 4, which is to take this and substitute it into one of my original equations. Doesn't matter which one. Could be equation number 1, could be equation number 2. I noticed that equation number 1 has all positive numbers, and I like positive numbers. So I'm going to use equation number 1. We'll take 3x plus 2y equals 4, and we're going to plug in 0 for x. So I have 3 times 0 plus 2y equals 4. Well, wait, 3 times 0 is just 0, so that's gone, and I just have 2y equals 4. Then, if I want to get y by itself, I need to divide by 2 on both sides of my equation, and I'm left with y equals 2. And look at that! I have x and I have y. So, my final answer is 0, 2. Now we're going to check and make sure that we were correct in just a second, but one thing I want to point out first is this is a lot less writing than substitution was. So, elimination might be easier for you than substitution, and that's why we learn all these different methods, is so that you can choose the one that works the best for you, that works the best in the situation, the specific problem that you're trying to tackle. So, now let's check our answer and make sure that we were correct. They also chose to add the equations, solve for x, plug it into equation number 1. The solution is 0, 2. Hey, that's what we got. Awesome. Fantastic. Okay, now what I would like you to do is I would like you to pause the video and try this one on your own. So, doesn't matter if you get stuck, doesn't matter if you can't quite finish it. Do as much as you can on your own, and then unpause it and we can go through it together. All right, let me look at my x terms. Hey, I already see that they're opposites. Positive 3x minus 3x, already opposites. When I look at my y's, they're not the same. So I'll ignore those because my x's are opposites, and I can work with that. So, easiest thing will be to add the equations together. 3x minus 3x goes away. 3 minus 3 is 0. X's are gone. They are eliminated. Okay, and 2y plus 4y is 6y. 7 plus 5 is 12. On to step number 3. Already on number 3, we're going to solve this equation. And the way I'm going to do that, step number 3 was purple. I'm going to divide by 6 on both sides to get y by itself. And 12 divided by 6 is 2. So there is y. We already have y. Wow, that was quick. Now we are on to step 4. Step 4 is green. And we're going to substitute this back into one of our original equations. Doesn't matter if we use equation number 1 or equation number 2, but again, equation number 1 has all positive numbers in it. So I am going to use equation number 1 because I'd rather deal with positive numbers than negative numbers. So equation number 1 is 3x plus 2y equals 7. And I'm going to replace y with 2. 2 times 2 equals 7. 3x plus 2 times 2 is 4 equals 7. And I can subtract 4 on both sides so that I can get x by itself. 7 minus 4 is 3. And then, to get x by itself, I will divide by 3 on both sides. I'm left with x equals 1. Ta-da! I have x, I have y, so I can write this as 1, 2, x, y, and we are done. Yay. Okay. That is what I have for you today, just an introduction to elimination. We're going to add step 1, make it a little bit harder in the next video, so stay tuned for that, of course. And now you know what time it is. It's time to assess your understanding of the learning target and the success criteria. So on a scale of 1 to 3, where 1 is no and 3 is oh yeah, where are you in understanding our learning target and success criteria? Do you know what elimination is? Do you understand why it's called elimination and how we do the process of elimination? And can you solve systems of equations with elimination? The last problem that you were trying on your own, were you able to do that on your own? So, assess yourself, rate yourself on the scale of 1 to 3, and then take the appropriate action. So ask for help if you need to, start on your homework and see if you need help, see if you understand it, and reach out to your friends, help them, teach your parents about what you've learned, something like that. Here are some practice problems that you can do to practice the skills that we have learned in this video. Notice how each one of these problems, either the x terms or the y terms, have the same or opposite coefficients. So all of these problems are just like the problems that we did in this video. And as always, let's end our video with a launch. This launch comes from Plato, a famous philosopher, and he says, "The beginning is the most important part of the work." The beginning is the most important part of the work. I like this saying because when we think of, the work could be anything that you want to do. Could be homework, could be your job work, could be exercise work, could be yard work, could be whatever it is. You're working on writing a book. You're working on writing songs, you're working on whatever it is that you're working on. And the most important part of that work is the beginning. Because the beginning frames your mindset for the entirety of the work. If you begin with this with kind of short-sighted, oh, I just want to get started, you might not actually finish it. If you start with, I'll try this, see how it goes, but I don't think it's going to go anywhere, that attitude determines, well, I don't think it's going to go anywhere, so it's probably not, and I'll just fizzle out. And if I start my work with, this is going to be difficult, I have a plan for how I am going to do this work, how I am going to succeed in this work, and I'm going to make sure that I follow through with that plan. I am capable of following through with this plan, and I will get what I want. That is the mindset that is going to get you through your work, and with a good attitude, right? Because it's easy to say, okay, I need to do this work, I need to pass this class, I need my job to have money, or whatever. It's easy to have the attitude of like, I'll get it done. But you can have fun doing anything, doing absolutely anything. I have fun doing dishes, which isn't particularly fun. I have fun weeding in my gardens, even though that's not particularly fun. You can make anything fun. It all depends on your attitude. And your attitude in the beginning of the work is what is going to set yourself up for success in that work. So, what's your attitude right now? And what is it that you are beginning or that you want to begin? Is there something that you could create a new beginning so that you can make a new attitude? Reflect on how this applies to your life. Can you apply this anywhere in your life? What are you beginning and what attitude are you going to choose to have? That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.